All right, well, let's maybe describe how we got here a little bit. So I think we made, Adam, I know we have mentioned Demo Friday in the past here, and our credo around demo-based development here at Oxide.
Yeah, I mean, I feel like bordering on extensively, but yeah, like demo day is a prominent feature.
And it is deliberately unstructured. So it's kind of it's a forum for people to demo stuff for their peers. Our kind of view is that your peers are, I mean, you get the biggest shot in your arm, I think. I mean, you get big shots in the arm, obviously, from customers and from folks that are looking at your work, but especially your peers, it's a big shot in the arm when you can show your work off to your peers, because they can appreciate some things that can be harder to appreciate. So we've had a lot of fun. We do this every week, and it's always been very uplifting and interesting. You kind of never know what's going to happen. I'm always worried we're going to have Demo Friday and nobody shows up, but I think it's happened once. I think that actually has happened. It's like, all right, no demos today. End of Demo Friday. But basically, it's there's always something going on. And so, Andrew, I did not know you had this one coming at all. And could you describe first the body of software that you have been working on, kind of what this body of software does, and then maybe we'll get to describe a little bit what the actual demonstration was.
Sure. So, I mean, I'm with you. I actually didn't know this demo was coming about a week and a half ago, and then I started working on it. But it was planned as possible from the beginning. And so, like, what we have is this giant rack, right, that users are going to plug into their data center, and they need to connect it to their network, and they need to connect it to an identity provider, and they need to do all sorts of initial configuration so that the control plane will actually boot and be reachable from their internal network. And so they can deploy VMs and do whatever else they need to do on the rack. There needs to be if the control plane's not up, there needs to be some way to actually log in and configure the rack in the first place, so we can set up the control plane. And so Adam and I and another colleague of ours, John, we sat down last February or so and started working out, well, what's that configuration actually going to look like? And we talked about using, various ways to do it with an API through the web, just have a CLI. We basically landed on some sort of CLI where a user would plug their laptop into the technician port, and that would allow them to do the low-level configuration. So go ahead, Brian.
How do we configure the network without the network? I mean, it feels like we got a bit of an inception problem. So how do we connect into this thing?
Yeah, so I am probably not the best person to explain how the switch works, but there are some, there's basically three sets of ports. There's the front-facing ports, the rear-facing ports, and two technician ports. And so the front-facing ports are the ones that connect to the user's data center, right? And that's what gives them their fast 100 gig networking. And then the rear-facing ports are the ones that I believe are just for inside the rack to allow sleds to talk to each other over the rack. And then there's these two technician ports, and these have regular old RJ45 cables, endpoints you can connect an Ethernet cable into. And so that's those basically open up into some sort of environment that allows you to do something to the rack, right? And they plug in those technician ports. Are reachable on the management network, I believe, or is it the Bootstrap network?
It's the management network, yeah. And we need to do a whole show on the management network because I think it's pretty outstanding. But we've talked in the past about the data network, like how all the nodes talk and how it talks, how we do, multipathing in a smart way and so forth. But there's another network, and actually there's yet another network, but the management network to control all these nodes out of band, and that's the network that this technician port is plugging into. So the rack rolls into your data center. You plug in with an RJ45 connector into to your laptop. Do a LLDP to discover the link local address and SSH in, and then we're in Andrew's body of software.
Yeah,
and this is a body of software that's going to basically configure this thing, and it's going to be effectively it's a terminal. It's going to be a terminal UI, and these are the apps that often these are essential, but can often get neglected. I dare say it, Andrew.
Yeah. So I certainly neglected it. I didn't think I would be the one to write it. I have many other pieces of code required to run on the rack. And I thought at one point, we were talking about making a web a web UI or something, but I figured there'd be somebody with some sort of user experience knowledge who would be building this. But apparently that is not the case. Although to be fair, I have worked with an NGR designer to correct some early mistakes.
It should be said that we chose a CLI because we really wanted it to work for everyone in every environment, and we didn't. This is you're setting up just the earliest small amount of configuration so that you can plug into the rest of the network, and we just wanted to keep it simple. From the sort of connectivity perspective and the technologies involved, we didn't want people like debugging JavaScript or whatever. We just want to keep it simple. And I say
we're not browser deniers, is what you're saying.
No, totally. We're browser maximalists for sure, but we just wanted something simple to get to the browser.
That's
but
right.
I would also say, Andrew, you talked about this being neglected software. What I sort of imagined was the most basic user interface conceivable of something prompting you 1, 2, 3, or 4. But Andrew has discovered an entire universe of TUIs, of text-based user interfaces, and has built something unbelievably beautiful.
Yeah, so it was very much by accident because Adam, I figured it would be just like what you said as well, especially if I was going to be the one building it. But like anything else, you find an interesting niche and you start digging in and having fun. And boy, was it a lot of fun. When you start having to make things real and get to the production engineering side, things can get less fun. But it's certainly a fun thing to dig into. So we do have there's a text user interface, and we talk to it through this technician port. And so there's a whole subset of software that runs here, right? And so where is the software running? It's running on what we call the Scrimlet, which is a server sled that is directly connected to the switch. And there is some magic routing that I am not going to discuss because I can probably not explain it well, but that essentially allows the technician port plugin, all that data to come over out a port on the technician switch. And so when a user does SSH in, it ends up in a Lumos land, and the SSH command runs our shell, which is called Wicket. So it's a captive shell. It's a text user interface. It's built on top of 2ERS and crossterm in Rust. And it presents the user with essentially like a graphical interface inside the terminal. And so they're SSHing in, and this is their login entry point to allow them to configure the system. And
it should be said that just in general, these are the kind of interfaces that Rust makes really easy and delightful to write. Honestly, there's a good crate support. It's been really fun to write these kind of applications.
Yeah, totally. And so credit where credit's due. I would not have even remotely thought of doing anything like this, but we have a manufacturing station that we also built by Josh Kulo, and he implemented a text user interface for it. And I was literally about to start working on this, and I was like, it was a demo Friday thing. He demoed it, and I was like, well, why am I going to do like a CLI when I can have this beautiful captive shell? Because Josh does have some aesthetic sense, and it was nice. And so I initially copied him, which it got changed later for various reasons.
Okay, I cannot resist pointing out an implementation detail of Josh's manufacturing software, which is all, which honestly, on the one hand, no customer sees. On the other hand, it runs on the manufacturing line. It's very important. The font that he uses is the same font that Sun had on the Open Boot Prom. And I mean, Adam, I felt like I teared up when I saw that. I was just like, we're home. We're
awesome
home, Adam.
Throwback, yeah.
Totally awesome throwback. Anyway, sorry, Andrew. Please.
No. It's like super impressive. And like at that manufacturing station, like Josh, I actually talked to him, and I was like, walk me through your mental state and like, what is your point of view on this type of software? Because like, if you know Josh, if you ask him that, like, he definitely has a point of view and like specific reasons for why he did something. And so I wanted to understand it and see like if I wanted to go down exactly the same path or something different. And so I did do something slightly different, but it was more because I knew this was going to live on the rack, and it wasn't going to be just me operating on it. And I didn't want to like write a terminal library from scratch. I wanted to reuse some available widgets, and there are third-party widgets. We're using some of them. So anyways, we have this text user interface, and it is mostly stateless. And what I mean by mostly stateless is that it talks to a downstream service called Wicket D, and that is what talks to other services on the rack, including our management gateway service, which allows us to talk over the service processors on each switch and configure the rest of the rack. And I don't know
All
if
right, so
Brian
now,
wants to get more into the service processors.
well, so at the moment, like, so now I want to jump actually kind of forward in time to your actual demo. So this is kind of all background to appreciate. And you had built Wicket and had demonstrated in the past and would make great progress on that in terms of walking this kind of the initial application effectively to configure the rack. But so now maybe fast forward to the demo. Also, the way you did it, you little sneaky guy. It was very you got an inner showman in you, Andrew. I was very in terms of the way you demoed it. So maybe you want to describe the demo a little bit.
Yeah, so unlike PT Barnum, we at Oxide are transparent in what we are selling, but that is not always true for internal demos. And so
I forgot that transparency does not apply in the first 2 minutes of a Demo Friday.
Yeah, and apparently, yeah, and secrecy also for keeping things fun. Those are only for fun reasons, not for any nefarious reasons, I must state. Okay, so I started the demo, and like this is like the third time I've demoed Wicket for various things. One was the initial, like after the initial prototype. 2 was after a redesign, and when like we could do some emergency updates where we could actually update service processors and ROTs through some software. So like that was the second demo. And so the third one, I was like, okay, I have some new functionality I want to show you. And so I essentially said like, watch closely, watch what I'm doing, watch the screen. And everybody's watching and probably going, okay, like what is this? I see what's going on here. It makes sense, but like I've seen this before. You're just walking through the UI, and then I just lifted my hands up, and the UI kept moving. And so it turns out what was going on was a recording, but it wasn't a screen recording. It was a recording of a live Wicket session that I was able to capture with a magic key press that I'm sure Brian's cat could learn. And that recording was being replayed. And then I went through how it works. Yeah.
Okay. Well, that's not true.
Okay. Well, my memory is terrible, so whatever.
No, you didn't go through. No, then it's like not. And then of course everyone's like, wait a minute, what? And then you proceeded to show this debugger that you'd written. Do you not recall this?
That's right. I mean, so the debugger is what does the replay. So okay, so I did.
But then you're going backwards. Yeah, good.
It did not go. This debugger is not reversible.
It did not go backwards. That was true.
It did not go backwards. It can be made to go backwards. I have built things that have gone backwards in the past. We are not using immutable like functional data structures, and so it is very cheap to capture the state. Or I mean, it is very expensive in the current system to capture all the state because we're making a copy of it all in memory for every step through a UI screen. Really not the way you want to build it. And I'll talk about the internals. But yeah, what I showed was that you can reset this. You can then kick off the play of recording. You load the recording through like a file, and there is like a little CLI. That's probably what Adam and I were envisioning for like a normal captive CLI built on something called Readline, which is a tool for new shell, and that's just like allows you to give you interactive command line driven abilities. And so what I showed was that you can load a recording from a file, hit play on it, and then as the recording is playing, you can also pause it, and you can resume, and you can show like what the current event that's being executed is, and then the internal state of the system at that point.
It's about now when Jordan is like, did I miss, like, what debugger are we talking? Did I like miss something? I mean, it's like, no one knows anything about this. But everyone is seeing this for the very first time. You got no idea what we're. So it was pretty neat. So Andrew, I think then you, at that point, you relented and explained kind of how you had implemented this, that allowed for this kind of replay debugging.
Yeah. So this is a technique that is fairly widely known, but unfortunately, like not widely known enough, I would say. And it's really, I mean, there's many different terms for it and different techniques, but it's essentially if you can separate your IO, your IO from your state, from your mutable state, you can basically treat all mutations of the state as individual operations, and then you can record those operations, and you can replay your entire history by just passing the operations through the input as the input to a state machine. So you have this mutable state, and the state takes a message essentially, and it updates its own internal state and possibly outputs something, some output messages, right? And so that's how Wicket is built essentially. There's an event loop, there's a global state, and then there are a bunch of messages coming in. And all this, all that makes this possible is that those messages are totally ordered, and we're able to serialize them and save them to a file. And then with that, you can take a live dump and replay all those events in order.
Andrew, I don't know if this is ascribing too much foresight to you, but I really got the sense when you were talking about this for the first time that you sort of had this in mind from the beginning, right? That as you were designing Wicket, that you were thinking about maybe not this specific debugger, but debuggability in its construction. Is that right? Or am I making you sound like a mastermind? Okay.
You have to do this ahead of time, right? Like if you start, so for instance, like Rust makes this, it's easy to build this, like it's easy to build many things in Rust, but you can't like do it after the fact. You have to separate your IO, like in any language. You have to do this purposefully. And so if you're writing, if you started out with a bunch of like Tokyo tasks, right? And those tasks were receiving messages and mutating local state and like spawning things, and the state was spread all over the place, you could never do that, right? You can never totally order those operations. And so I knew from the beginning that I wanted to totally order things because it makes the system easier to understand. But like that's what a UI is. Like UIs have been built this way for a long time, as far as I know, right? At least, I mean, it's possible that I've only read like UI papers from the 70s and 80s, but like essentially, like there's some sort of main event loop, and interactions are getting pumped through that. I think this is like somewhat how like GTK works and other things like that. The main thing is that you separate all kind of mutating states, separate all your state mutation from like any non-deterministic operations. So one other thing you have to do to make this work is that there's two real, in this scenario, there's two main cases of non-determinism, three. So there's events flowing from the downstream system, such as like a sled gets pulled and an event fires up, right? Saying, okay, here's an alert, this sled is no longer there, you want to update the UI. There's also a user pressing a key press to say do something, and that should trigger a redraw on the UI. And then there's the third thing, which is just time, right? If we want to animate things, and there are some animations in this UI, we need to have like a regularly timed tick operation. But like you don't want to just have the main loop, like setting a timer and then processing that concurrently, because now those ticks are not ordered with respect to the other events coming into the system. And so instead we have this channel, really a queue, which allows us to totally order all those events. So anything coming in, user key presses, downstream events from the rack, and timer events are all normalized into a Rust enum and then popped on this channel. And so now you have a total order. And that total order just gets replayed through the state machine, and the state machine looks at what's happening and says, okay, what do I need to draw now? And there are some optimizations there to like not draw when we don't have to. Another idea I got from Josh. But it's essentially, we're feeding all these things into a single threaded event loop. And there is Tokyo in the works, but that IO handling, and whether it's asynchronous or synchronous, is totally abstracted out from the main loop, which does the drawing and allows us to replay that drawing in a debugger later on.
Yes, I mean, a bunch of important stuff there. One, I think and you said this, but just to really underscore the point, like separating out your IO from your logic is really important. And it allows that, because there's just so many positive things that come from that. And conversely, when your IO is convoluted with your logic, there are so many things that become just much more difficult. It's like having a 2-pack a day smoking habit. It's just like, oh man, there's going to be so many health problems now that are just going to be really hard. And it's like, actually, if you can separate this out, there's a lot of things that positive things that fall out of it. One question that was in the channel intro was, were you inspired at all by Elm, which I know has taken the programming language for web browsers. I don't know if you've talked to Crespo about his affair with Elm, but really interesting language.
No. So like, I am not a UI person. Like, this was, I won't want to call it my first like terminal UI or whatever. Like, I've worked on a few things, a few toys before, like in college and elsewhere, but no, I haven't done any real UI work, and I was not super familiar with Elm or how it worked. I learned about that actually while I was doing this. I was trying to dig up papers, and I learned that this is very similar to the Elm architecture, but it was after I kind of made this decision. So like, this decision really comes from my background, which is building like distributed systems, and in particular like consensus systems. And so if you want to model like a consensus protocol, you have a bunch of independent actors and they all maintain local state. And you can't, in reality, you can't get a total order of overall events because they're remotely located, whatever. In a simulation, you can certainly do that. And so if you model it the same way, where each replica or actor in the system has its own state and is just getting fed events, no matter if those events are coming from the network or from a debugger, you can write property-based tests, and you can do all sorts of things to ensure that each independent system maintains as you want it as a whole. And then you can also pass output events and messages between those replicas, all single-threaded, right? You can basically run your whole system, your whole consensus network in a single thread and totally order everything and make sure that global invariants are upheld, right? This is not a real test, right? You're leaving out the network, you're leaving out a lot of non-determinism. But like, if you can get that thing's working and the inputs, the only way you can get an input into these actors is through a message, then you're pretty confident that, like, barring stupid bugs, that your system's going to behave the way you want it to behave. And so I just built it like that. Like, I said this is the second time I built a debugger like this, and the first time was for another project I was working on at VMware, that sadly got canceled for unknown reasons.
Right. I'm sure like really awesome, well-founded reasons had nothing to do with the
always a good decision. Yeah, always
well explained and articulated to everyone.
Yes,
that's right.
Very clearly spelled out. I have no confusion about it whatsoever.
And good news, and no lingering resentment. So it all worked out.
Yeah, so I started building that from no lingering resentment at all. I didn't not every other position I took after that was not a slight disappointment. It was fun. No, I don't get me wrong. My time at VMware was great for the most part, and I worked on a bunch of interesting projects. But the thing I was hired to work on lasted a much shorter time than I expected it to last. And so it was implementing that project was something called Herit, and I was implementing view stamped replication, the view stamped replication revisited paper from scratch. And I was doing it in Rust, and this was June of 2015. So if you know your timeline, Rust had just gone 1.0. There certainly was no Tokyo.
Adam, when is that relative to your blog entry on Rust? That is about the same time, isn't it?
Oh, geez, yeah, I got to look that up. What month in 2015 was that?
June.
Yeah, that's
right around that time. Yeah.
Right. This is my first introduction to Rust, is reading Adam's blog entry. And I was like, okay, well, in conclusion, I will never use this language. This sounds exceedingly painful. And Adam's last line was like, in conclusion, this is kind of interesting. I really enjoyed this. And I'm like, did you read your own blog entry? But I mean, I think that it was a painful time in a lot of ways. I mean, there were things that you could tell when I arrived in 2018 that just gone through a big step function in terms of reducing pain. But I think in 2015, Rust was raw.
You had to really want it. I mean, there were lots of times when the compiler would tell you to go fetch rocks and then tell you those aren't the right rocks. Go get some other rocks.
That is very accurate.
Did the Rust compiler from 2015, did that prepare you for being a parent of a toddler? Adam, it's just like, you know what? I was a Rust user in 2015. Like, you're going to have to do more than this, kid.
I would say certainly better than any other programming language. I mean, C++ is like close, but a little more psychotic and less sort of arbitrary.
Well, and this is where you also have certainly the ownership model was certainly new to me with Rust.
Yeah, new to me as well.
Adam, did you just say C++ was less psychotic?
No, pardon me. A C++ more psychotic kind of less arbitrary in its whims. I'm just thinking about which language prepares one better for having a child.
Fair.
Yeah, I mean the memory unsafety and kind of the rampant data corruption definitely helps you prepare for being a parent, I think. And
yeah, every child's different, I think, is the short of it.
Exactly. But so Andrew, you had been a the Rust user in those early days, and so because one thing I would love to understand is building this debugger was super fast once you had this whole thing built out. It was like days, is my understanding.
It was about 2 days, which, like, at least to start it, right? It's actually wild. At a point today, so it's been a week-ish, and now it has, like single stepping, and you can do a few fancier things. You can play at different speeds by manipulating the tick time. Since we're just sending messages, we can choose how long to sleep when we see a tick message in the debugger.
And has this been useful for debugging some problems that you've encountered while developing this?
No, of course not. It's a total toy right now. No, the real purpose. So part of the reason I did it was because I knew we could, and it was a weekend, and I thought I could get it mostly written over the weekend. Because I don't know, I was bored, and I didn't want to do real work. I had started working on like a real thing for work, and decided I wanted to do something else that was tangentially work related, which is honestly how most of my projects go. Like, most interesting things that come out of my head are very like immediately relevant to the work I'm doing, but not strictly on the path to shipping a product. And so that's how this popped out. But like, I had the idea that I wanted something like this. I wasn't sure it was necessary, but then I get excited. And so like the real driving motivation, besides just me being bored and like really wanted to build this because I thought it would be cool to show visual state, was that we have to add. We were talking about so a coworker and I were talking about adding progress bars, and also like we're trying to get this system running on what we're calling the dog food rack, and I don't have full access to that rack at all points in time. And so I was thinking, well, it'd be nice if I could just simulate all the events I want in the UI, so when I add animations or change styling, I don't have to walk through and be plugged into a real rack to do this. But I want to look at it as a human. I'm not just looking to like run a test and see if it passes or fails. Like, I want to see how it looks. I was like, oh, would it be neat if I could just, step through all the important parts of the UI that I care about while I'm making changes, and then just run the recording after I make a change and see what it looks like.
So that's what, and you demonstrated that. That's what I actually love. It's like, all right, so let's see if we change this color, or we change the way this thing looks, or just we're going to make some cosmetic change, and we want to like really understand quickly how that's going to look, and now we can just go replay it and see and get to this, which I thought was really neat.
Yeah, and so like you can see, so I don't think I did that on the demo. I mentioned it, but like I did do it for Benji the other day. Benji's our designer. But like you can you can see where there's bugs. Like, okay, so for instance, I created a little like style module, and it just contains some colors and like names them through functions, right? It just says like, for plain text, make it off-white, whatever our specific off-white color is. And so like you change that, and if you change that, you're going to see all the places you're using that as you run through the recording. And like when I first made the change, I noticed that it did not change where I thought it was going to change, meaning that something was hard-coded in that place, right? And so that was like really nice. That would be a really hard bug to catch. But like when you're just watching it and you see all the colors change, except this one thing you expect to change doesn't change, then you got to go fix that spot. And so like there's unexpected, like serendipitous bugs revealed to you that you probably wouldn't even notice if you were slowly like manually walking through things, unless you were looking for them.
Well, so there you go. That's your answer to Adam's question. Has helped find bugs. That's great.
Yeah.
And Andrew, could these event streams also form the basis of like CI, where you're kind of taking some recordings and replaying them into the new code to validate that everything's working properly?
Yeah, so this was a larger idea I had that I'm not sure I want to build in particular, or at least not right now. But you can imagine that these events are coming through and they're manipulating what is essentially a bunch of rectangles on your screen. And you can write some tests that say, when these mutations come in, I expect this rectangle to look like this, or I expect a modal to be up. If a modal's up, then like the background should be this color. And you can actually copy out the buffers, right? And then check after you run some operations that the buffer mutations look as you expect. So you can totally automate like what the CLI is supposed to be with 2ERS. Like you have full access to the terminal buffer. It's not that big because it's just like some characters on a screen, right? It's not a full like 4K resolution thing. So yeah, you can write tests through that, and like I thought about it, and so this system is that we've talked about recordings and how you can play your recordings. So 2ERS and Wicket allow you to resize the screen. So I operate in tmux a lot, and I resize the screen so it's like small, like a laptop screen, like it will be in the data center. And when you resize, the placement of everything changes. And so if you were to use take your recording in a large screen, and then without doing any resizing, and then run it on a small like debugger window, it's probably going to crash. Just because the resize events are ignored right now in the debugger, and it's going to try to place things outside your terminal window, like if your window is too small. But that is just like an artifact of not implementing that functionality yet. You could imagine that if we know we're running in tmux, we can automatically resize the window. And Rain, my colleague, they pointed out that you could actually use like a PTY, and so have like a virtual screen that's always the right size, and then process resize events that way. So that would be a cool way to do it, but I haven't dug into that yet. So right now we're just using this to iterate fast on debugging, but it also is running in production, or well, nothing's running in production now, but like it could be. It's enabled so that you can store up a certain number of events and then dump them if you see an anomaly.
So Andrew, if we're in the data center, sweating next to the machine, and something goes wonky, we can hit a keystroke and it'll emit this stream of events to like bring back home to diagnose what went wrong.
Yeah, exactly. So it just dumps it to a text file, which you can configure a location. It's not text; it's serialized. What am I using? CBOR, for a number of reasons.
Oh, gotcha.
Cool. But yeah, there's another interesting component there, which is like, okay, you have this stream of events. Well, how long are you going to be sitting at this screen messing with it and ticks going off? Like, you can't let that stream of events build up indefinitely. You will take up a lot of memory, and your files will get quite big. And so, like, you typically want to constrain the history of events. And again, because we have a state machine and we have access to our global state, we can take a snapshot of that state when we have, say a max number of events, or we've used a certain amount of memory. And that allows us to keep like a fixed memory usage while this is running, and not kind of destroy the machine, which lets us use it in production. And so, like, let's say you have 1,000 events, and that's all you're allowed to record, and that'll give you whatever 10, 15 seconds of recording time. Once that initial 10, 15 seconds is up, you take a snapshot, you clear out your vector of events, and you start building up from there. And so what that means is when you take a dump, you're not going to start from the beginning. You're not going to start from the Oxide splash screen. You're going to start from wherever, within that last event window. But everything will still be consistent. And so if you have a couple minutes worth and you see a problem and you want to hit a few keys and see what happens, you can just do that and then know that like 30 seconds later when you hit the hotkey to take the dump, that it'll have the anomaly that you want to capture.
Well, and that seems huge for the kind of deep menued system that we're building there, where if you want to debug, the 15th step that someone's taking, or not even debug it, but if you just want to kind of keep on building on it, it's such a pain in the neck to have to start from the beginning each time. So this thing fast forward you to the part that you're interested in. That seems like a huge time saver.
Yeah, well, and also, and I love just the ability, obviously, to debug postmortem. I mean, as our colleague Cliff said shortly after he arrived at Oxide, y'all are really into postmortem debugging. It's like, yes, we are really into postmortem debugging, but just the ability to have that state that can then be sent elsewhere for purposes of understanding the system is just extraordinary. Yeah. Andrew, something you said briefly that I want to go back to, because I think that this was in Rust allowed you to extend it in this new way, or develop this kind of extension in terms of the debugger really quickly. So, and I know, yeah.
All right, continue. Sorry, continue with the question. I didn't mean to
Well, I was just going to say, and for anyone who implements in Rust, this will be old hat. But for folks that are new to Rust or haven't implemented in Rust, they may not realize the load-bearing role that it has here, as it has in so many things that Serday is playing here. Serday makes this super quick to implement.
Yeah, so that is very much a key, right? Like I cheated, like I have on so much other software, right? Like if you were working in C++ or other languages, there may be similar functionality, right? But like Serde is the serialization and deserialization library built into Rust. So I was talking about Harriet before. Serde also didn't exist when I was writing Harriet. There was something called
I was
Rust
going to ask.
Serialize.
Yeah.
It was the precursor, and it was okay. It was much slower, and it was definitely not as well documented, but like it worked. So I was able to cheat back then as well, just not as well. Like the cheating wasn't as effective. I got like an 89 on the test.
But so, and describe a little bit how one uses Serde, because this is what I think is remarkable about it, is how
Yes. This is like just amazing to me. Like this blew me away. So like I've never personally written a procedural macro. I have some knowledge of how they're built. I've briefly looked into it and always gotten distracted and gone on to something else. But I have used procedural macros in pretty much all my code since I started dealing with Rust. And so what a procedural macro does is it allows you to essentially give an annotation to some part of your code base, and it will automatically generate code by reading that code and modifying it according to what you instructed to modify with your annotation. And so for Serde, what it does is it takes a structure or any sort of data structure in Rust, and you can annotate it with the Serde serialize and deserialize tags, and that will automatically generate serialization and deserialization code. And so that is what allowed me to very quickly hook this up to just writing things to a file. So one question that arises, okay, like, well, what serialization format? Well, that's the great thing about Serde is it's pluggable. And so it defines like a visitor pattern, and then there are different serialization formats that implement the Serde callbacks, essentially. They implement the serialized call for Serde, and so the Serde proc macro uses them or generates enough information. I'm not fully aware of like what the path here is. You can combine various formats and Serde itself, and then all the user has to do is say use this format and use Serde, and it generates serialization code of the right format for you.
Well, and importantly, deserialization code, because serialization code is, I mean, it can be a pain in the ass, but it's actually like it is much easier to write serialization code than deserialization code.
Yes.
And rarely is one good without the other. So you needed to both serialize and deserialize here. And I mean, I've just found this over and over and over again, where the ability to just literally annotate a structure by denoting that it's going to derive the serialization and deserialization traits, and then like it all happens just magically, and you get this really robust deserialization, which is I feel that certainly speaking from my past self, I mean, I would YOLO the serialization, and the deserialization would be for something like this would be just the max power way, as we say, making a Simpsons reference, the wrong way but faster. And whereas when you use Serde, like you're actually getting like really robust deserialization here as well.
Yeah, it will not deserialize. So, I mean, it depends what format you're using, etc. But like when you say deserialize this struct, you know essentially what type you're going to be deserializing into, and Serde will attempt to deserialize into that format. And if it doesn't, it will give you an error and it'll tell you where it errored out. That's not true for every like implementation of every format in Serde, but it works pretty well. And like the way Wicket is using it and the Wicket debugger is using it is it's kind of the interface between the two, right? Like Wicket, like these were separate commits, right? Like Wicket, I had the serialization code. I dumped out all the events of the file. I created the snapshot format, which has that state that we talked about and the events. And I dumped that out to a file, and then the debugger came later. It just read that file, deserialized those events, and played them, replayed them. So there was some abstracting of shared code so that we would play things the same way we do in actual Wicket, so that like you're not writing two separate implementations that can diverge. And so there was a little trickiness there to get that how I wanted it to. But for the most part, like the interface layer between those two things is just serialized events. And it's automatically serialized. Like I didn't do any work to like pick, do anything with that format.
Yeah, when I kind of feel this is like one of these examples, right? And I know there's a lot of discussion happening out there about where is Rust a good fit, where is Rust not a good fit. But it's the presence of this kind of stuff that at least at Oxide we see a really broad use case for it up and down the stack. In pretty much, it just feels like there's lots and lots of software that would benefit from this pattern and this approach, and kind of the ability to have a language and environment that can do that has been a big win for us, I dare say.
Yeah, I mean, in the past life, I've used Pickle for Python to do something quick and dirty like this, and I wrote like our own IDL, like protobuf IDL for my past job, in C++.
Yeah,
There was nothing
I did one of
appropriate.
these. I did one of these in Perl. That was a mistake.
That was probably like 2004 or something. I don't know. I feel like you can, based on the language, based on the choice of Perl, you can really pin it down.
Yeah.
Well, no, no. Sadly, this would have been 2004. It tells you something that I was doing this in actually 2008. So I probably it'd have been 2004. Maybe it was more defensible decision, but and that was actually where I ended up redoing that CLI in JavaScript, actually in Node. That was kind of or in JavaScript, that wasn't in Node. My first kind of realizing that you could use JavaScript and it was useful, but boy, nothing compared to what we can go to with Rust and being able to apply this just ridiculous power tool throughout the stack has been great. And then, so Andrew, in terms of like applying this kind of pattern, because this kind of feels like all of the fun of distributed systems without any of the like real pain in the ass of distributed systems. Am I wrong about that?
No, you're exactly right, because there are no communicating processes here. Like, I'm just reporting events from a single threaded thing anyways, right? Like, yeah, there are downstream services, but like those are just REST services, and they're just like, we're just polling them and grabbing like inventory updates. It's not, there's no complexity on the distributed systems front here. But when I guess like what Brian said to me early on is like, as semi, elderly engineers, like we have this synthesis of knowledge, right? And you learn that you can combine things and take your experience from one place and use it in another. It's not always the best idea, but in this case, it worked out nicely.
Yeah, where I do think that, and I think there's also a lot of value in when you've got these parts of the system that everyone is kind of looking at someone else to go implement. That is really important, right? This is the first actual software that a customer runs on the rack is the software. And instead of viewing it as regrettable, you're viewing it as a real opportunity to like, okay, wait a minute, I don't have to implement this in the same way that it's been implemented. I can actually apply all of these new techniques. And how can I go do this in a way that's going to make it faster to implement and it's going to make it more robust and so on. So I think that there's a lot of value to that kind of versatility where you're going into a new domain that is, and you said like, this is not, you don't do a lot of UIs and a lot of terminal UIs, but this is a real opportunity to apply that distributed systems wisdom to a new domain.
Yeah, really, you should take any opportunity. I mean, me personally, I do not mind digging into new domains, like as long as I have the time and the right support system, right? And Oxide's great for that. Maybe not so much on the time front lately, but having like just the ability to dig into something new is great. And like if it's needed, like you feel that there's value there, you can go dig in. But you learn. I mean, there's just an ability to learn something new, and really like you can really dig deep. And like essentially, this was totally demo driven development. Like I did this to show off my peers. I wasn't like, this was not like, I don't know, like this definitely adds value, and I think the customers are going to like it. I think it looks great. I think it's going to look better for real. Like it'll continue to get better with more people working on it, right? And more design like skills and coordination across everything. But like the impetus for it really was to like make it look cool for the demo at first, and see how well it worked if I get it done right. And so like the first iteration of it was about 2 weeks worth of work, and had a bunch of like very weird like UI rendering, and it had like mouse over events, and like the bulk of that was thrown away, but like the core of it being a text user interface and showing a rendering of the rack and other things were kept. And so if you have time to experiment, it's always fun to step outside your own comfort zone and see what you can do. Like honestly, that's been my whole experience at Oxide. I have an interesting position. I came in thinking I was going to be doing one thing and kind of did a bunch of other stuff. It's been interesting.
Just like at VMware.
Yeah, that's true. That's true. In a different way.
Yeah, in a very different way.
Yeah.
You know, I want to make a joke about canceling projects, but I can't even do that. It's just too cruel. I so hate it when it just brings up this is in many ways like my there are many aspects of Soul of the New Machine that merit a reread, but the fact that the birth of that project is when one project prevailed over another in the shootout at Hojo's is where they and that definitely stuck with me reading that on the second read. Sadly, all the shootouts at Hojo's, but no shootouts at Hojo's at Oxide. So this is all very, very good stuff.
Yeah, I mean, we have so much to do. It'd be hard to have a shootout. Like, I think we can all find our own domains to be dominant in.
No, exactly.
That's right. No reason to like try to squeeze someone out. Brian, you broke the seal on JavaScript. I did want to mention. I mentioned this to Andrew. Have you checked out this thing called Replay.io? I learned about it because our colleague Justin runs another podcast called DevTools.fm, which is great. And he had recommended this episode, and it's a replay debugger for JavaScript in the browser, which sounds tantalizing. The internals of it are ludicrous because, like, it has, JavaScript in the browser has none of the properties that Andrew was able to take advantage of. And so they're basically both interposing on system calls to get at those raw events. Yeah, exactly. Taking advantage of the fact that JavaScript is, mostly single-threaded, but then also getting deep in the underwear of the virtual machine in terms of like locking primitives and stuff like that. Anyway, a neat system. It reminded me of some of the stuff Andrew was talking about, and he's built in the Wicket debugger. But also, like, you need to start recording from the beginning of time, and desynchronization is a huge problem. Anyway, neat system.
When you also have, there's this kind of tension about how general purpose versus special purpose your debugging infrastructure is. And that there, on the one hand, if you've got general purpose debugging infrastructure that can debug any program or debug any JavaScript, you can, obviously, it's got a very broad surface area. On the other hand, it can be really nasty to get a lot of that stuff to work. And I mean, the one thing I love about this, Andrew, is this is very special purpose debugging infrastructure. This is just for this application effectively. But as a result, it's extremely powerful, and there are a bunch of problems that you don't have to solve because of the way you've architected the application. And I think that we don't spend quite enough time on application-specific debugging infrastructure. I think it's really, really powerful, and I think that it so often will help inform good architecture decisions when you think about this from the get-go.
100%. Like, this is the same. I mean, you can make the same argument for certain types of testing. Like, I don't buy the whole, like, necessarily, I don't want to get into this rabbit hole, but like test-driven development, building out the perfect architecture by, writing your tiny unit test functions. But I do think like more sophisticated testing strategies can let you know when you can't see whole subsystems in your test process because they're just inaccessible. So like property-based testing, I think, is a good way to exercise large portions of your system with a large input space.
Can you elaborate on property-based testing? Because I actually had not really seen it prior to Oxide. I know it's out there, but could you just elaborate on it a bit?
Yeah, so it's actually kind of similar to what I built here, which is that you have at least the ways I would use it for distributed systems. So there's two sub property-based testing. I guess the simplest way to describe it is you would have a function. Let's say you have a function that reverses, like, all it's going to do is like reverse twice. Let's say that this is a simple like example that most property-based testing like tutorials go through. It's like you have a function and it's going to reverse a list twice. And when you reverse a list twice, the property is that you should have the same list you started with, right? So what property-based testing does is it generates a bunch of inputs automatically, giving like, so you give it some sort of generation function, and it'll generate inputs that correspond to the right type, and then the test infrastructure will do that, and then it will run through your actual function. So you're not writing 7 or 8 individual tests, giving like various tests manually, giving like various inputs manually, saying like, here's a list ABC, here's a list ABCD. Like the property-based test will generate those, and it'll start growing them and getting more random over time as it runs. And so it's just testing that the property that you want, you can name that property like reverse twice, gives me the original list. That could be the name of your property. And all it's doing is checking that that assertion holds given a set of inputs. And so it has to be deterministic. Like otherwise you're going to be in a world of hurt. Because like if your test just started not doing that properly, that would be bad. But, like this is why like the separating your IO and making things deterministic. This is how I kind of learned to structure my code that way, and how I ended
Yeah,
up with
interesting.
learning to build these debuggers. Because in order to make distributed systems property tests deterministic, you don't want to just like you don't want those tests to call into like the local clock while they're running. You want to pass in the time or the duration or an expiry event, right? And so that way, every time you run through and you get that same order of events, you're going to get the same result in the test, and so they're not flaky. And so like you want that stateful manipulation. And so like that's the simplest form of a stateless test would be just generating a bunch of inputs and passing it to a function that's like a pure function, right? But like there's also the stateful version is you have an actual model. You have the state of your system under test, and then you have a model state. And so you're actually writing a separate state machine for the model that's perhaps simplified, and you're running the events. You're generating a list of events again, and then you're running it through the model, and then you're running it through your system under test, and you're comparing that the model, your assertions, your properties now are that the invariants for the model actually hold and match like the system under test. So for instance, you can say the sequence numbers will never have duplicate sequence numbers in this replicated log. So like you'll never see you'll never see diverging agreement among all the replicas. And so all you need to do to keep track of that is to essentially maintain in your model that the replicas. All right, I'm confusing myself right now. But in essence, like you're maintaining a model and you're maintaining the invariants for that model, and then comparing them to the system under test and making sure that they match. And the property-based testing part of that is just generating the inputs and running through those assertions and invariants and allowing you to see if they match. What makes it really interesting is that most property-based testing tools, when they fail, they give you a history. And that history can be really long and complex. But they run through and they through a process called shrinking. And shrinking actually reduces the state space. So it steps through, it kind of does a binary search to see where the test would fail. So it starts running tests with similarly patterned inputs that are smaller to try to see if it can get the minimum sequence of events that cause the test to fail. And that is a really nice thing because that allows you to more easily debug it. So like if you have two things, if you have the property-based testing infrastructure that can run through your system tests and show you the failing history, and you have a debugger that knows how to play those same events, you can now take that recording of the failing test and run it through your debugger, right? And so these would be all application building. But if you structure your code that supports property-based testing, it's most likely going to support this type of event replay debugger, and you can use the actual failing test to run through the debugger and inspect the state and see what's going wrong.
Yeah, that's really cool. And so Adam dropped in a link to the PropTest crate, and I think that this started. My understanding is with QuickCheck. So Nick in the chat dropped in a link to QuickCheck from Haskell. And is this kind of coming from the Haskell side of it? I mean, have you used what have you used for property-based testing?
So I believe it was introduced with Haskell for QuickCheck, and that was like a John Hughes jam. No, that was a Simon Payne Jones jam. But John Hughes was the so I first started with property-based testing in Erlang when I was working at Basho, and so wrote a lot of property-based tests and stateful property-based tests. And we used a proprietary tool from Qvik called, no, it was like Erlang QuickCheck. It wasn't a very creative name, but it was an awesome tool, and it actually did much more sophisticated things than either the original QuickCheck, as far as I know, and like any of the open source tools for Rust. Like it would generate symbolic inputs, and so it would like symbolically shrink the state space, and it had all sorts of funky stuff. It would also do randomization of the like runtime, so it would not only like manipulate the inputs, but it would also manipulate the Erlang scheduler under the hood through something called Pulse. And there's a Tokyo project, I think it's called Loom, that does something similar to test like Tokyo. And so it manipulates like the state space or the underlying like schedules of the tasks that are running. But then when I was working on Harrod, PropTest did not exist, so I used QuickCheck, the QuickCheck implementation at first, and I kind of built up on top of it to build a debugger there and write some tests. But here I've used PropTest exclusively, so I haven't written as many property-based tests as I would have liked so far. But yeah, I use PropTest at Oxide.
And would that be your recommendation for folks that are familiar with
Absolutely.
Rust and looking to get
Yeah,
into
so
property?
QuickCheck, they're different, right? Like QuickCheck is a cool tool. I think it was influential. QuickCheck for Erlang, I'm talking about, and that it introduced the arbitrary trait. But with QuickCheck, like there's a why like PropTest versus QuickCheck, I think in the PropTest book. And so like there's a doc, an ebook that comes with the PropTest open source stuff. And it explains that like QuickCheck does its shrinking and generation based on types. But like you define the shrinking and expansion, like generation and shrinking from PropTest are much more coherent. So like you can derive, you can take a type and then compose them and like generate new outputs that aren't strictly mapped to like a Rust type. And it will shrink in the same order that those outputs are like derived. And so like it always kind of does the right thing. You can do a few more complex things, I think, with PropTest, and it's got a few more tools at its disposal. And it's got a really nice like introductory book. I think they say it's mostly feature complete. I don't think they're accepting like new features to PropTest. But it just works. Like you can build things on top of it. I would recommend using PropTest.
Yeah, this is something I really need to personally add to my arsenal. I really have not. Adam, have you used PropTest?
No, you and me both. That link to PropTest is like one of my forgotten tabs of like must-read material that seem to pile up at an alarming rate at Oxide.
Yeah, I will say like don't be intimidated. It's much easier than probably most things you guys have done. It's probably slightly easier to use than implementing dtrace.
But is it easier to use than using dtrace?
Yeah, but I'm semi-elderly now, according to you.
Semi-elderly. Oh, thank you for that, Andrew.
Yeah, well, I don't know.
So and actually, this is kind of like, and we should actually be fun to do an episode of this. That the Uasis, I'm probably mispronouncing that in the chat, is pointing out that a lot of the stuff that I would say we like about Rust existed first in Haskell. So build RS and quote, derive macros, traits, etc. Which is kind of interesting. I mean, it's actually, honestly, it's part of what I love about Rust is that it is drawing on a bunch of different folkways. And I look forward, I've joked with Steve Klabnik that I personally look forward to the Hopple talk on Rust about pulling in all these different things, because if you had told me a decade ago that there were things in Haskell that would be really meaningful to me, I would have been curious for details, because that would seem implausible.
Curious and incredulous, yes.
And curious and maybe incredulous. Yes, maybe incredulous. In part because I think that what Rust has done is kind of taken a bunch of, Haskell is going to get myself into huge trouble here, but Haskell has neophilia, right? It's like it's a great laboratory for exploring different ideas, and when you combine all of those ideas, Adam, do you remember being at AA Debug in 2003? Obviously, you remember.
How could I forget? I one of my favorite conferences I've ever attended. I say somewhat ironically.
I say that completely seriously. That was so much fun. This is so Andrew. This is the Automated and Algorithmic Debugging Conference, and which we were. I was so. I thought I was going
so much fun, but maybe not my favorite conference. But I did have a great time.
That so much happened in that conference. There was
yes.
I felt like I was going to the Olympics. I was so excited.
Because they didn't have it every year, and Brian had gotten a terrific paper in, and we thought this was going to be truly the Olympiad of people who loved debugging as much as us.
And it was a ragtag band that there were like 60 people there, half of whom were. I definitely learned about the French prologue mafia. Do not mess with those people. Like, you will end up in a dumpster if you. Do you remember they had some sharp opinions about prologue. But then, do you remember the person presenting on Haskell and needing to solve an NP-complete problem that generated an error message? Do you remember this?
I do remember this. Yes.
I'm thinking, wow, what a language!
Language. Oh my goodness.
We got to do a traveling salesman problem to actually get to go to TSP to actually Hamiltonian circuits in order to be able to generate an error message to understand why your type inference is failing. Which that was kind of like the only thing I knew about the language for a long time. So it definitely did not feel like it felt implausible that it was going to have immediate impact, but it definitely has.
Also, dear listener, for you thinking, oh, like I can't wait for the next AA debug so I can attend. That was actually the last AA debug.
That was the last AA debug because they can't get a space. They got kicked out of the Denny's or whatever, and now they can't get a space. I mean, it's really pretty sad. And we thought it was only happening every few years, every Olympiad, because it was so extraordinary that you just couldn't have it every year. But it's like, no, they can't get their shit together every year. This is also the conference in which, a couple of things. This is the, Adam, you had the idea when we were leaving. You told me that you were very upset that California had taken away our right to eat horse.
Yeah.
And in particular, as California is wont to do, we had just passed a ballot initiative banning the human consumption of horse meat. And you taken that as a personal offense, I think it's fair to say. And you were like, I never wanted to eat horse meat, but now obviously I do. And we're going to Belgium for this conference, Ghent, Belgium, amazing city. And we are gonna. I just remember you hatching this like when we were leaving. You're like, I want to eat horse in Belgium, and I just felt like I was my calling to help you on your quest.
I mean,
I'm sure I'm in. Let's go.
I always think of horse meat when I think of Belgium.
Well, okay, there you go. So we are now it's important to say that this is like definitely pre internet on the phone era. This is 2003, so it's like post internet, but kind of like barely. And in particular, we have got no way of, and we don't speak the language. I mean, it's Flemish. I speak French.
They speak the language, our language. But yeah.
Yeah, but we're looking for, but we're looking for horse. We need to go. We're looking for horse meat. We need to be able to go into
like a common, yeah.
Yeah, what we learned is that like horse meat is not actually. You can't just like show up in Belgium and ask for horse meat. It doesn't work that way.
Actually, we learned something else too. We learned that horse is slang for heroin, and everyone at the conference thought that we were really trying to party extremely hard, even for AA debug.
Well, because we said we wanted to score some horse, and it was illegal in California. As long as we're in Belgium, we wanted to score some horse. And they're like, "You guys look like you have your okay. What?" It's like, no.
We were just gonna have some beers after it, but I mean, you guys do you.
Come on. When are we gonna get back to Belgium? Let's get some horse. And then no, it's not. And then we had the whole water zooey fiasco, where it turns out we thought we were convinced that water zooey was horse, but it turns out that was hippopotamus. Yeah. Were they serving hippopotamus at that restaurant? I feel we never got to the bottom of that. That feels like that would have been even more exotic. Anyway, we finally found, and then we finally passed. And Andrew, just to your point that you think of Belgium and everything of horse meat, we passed a butcher shop that had a giant horse's ass, right? Adam, am I imagining this?
Yeah, no, this is all true.
This feels very dreamlike right now, but there's a giant horse's butt like hanging like a shingle outside of this thing. We're like, these guys have to have horse. But I feel like, did they have horse in the end?
No.
You sure it wasn't like a centaur and you just didn't see the front?
It might have been a centaur.
We went the short story made very long, but we got no horse.
It's a shame.
Well,
I feel good for the horse.
You were going to make it even longer by having we got no horse, but the store was closing in 10 minutes, and I had no cash, and I had to run across town for an ATM.
Yeah, we had another inspiration, which is we wanted illegal cheese. That is to say, unpasteurized raw milk cheese. That was our downgrade from horse. Yeah,
from horse. Yeah. I'm sorry, everybody. This is way better here. This is, when Andrew said semi-elderly, I just obviously took offense to that, and I want to show that I'm actually full elderly by just.
I was paraphrasing.
Semi-elderly.
I thought experience was the word I was looking for.
Right.
I take it as praise.
Rambling
I take it as
story.
praise. Look, exactly. It goes on and on and on. And there was a horse's ass there.
Yeah.
Give me 2 B's for some horse, you'd say. Andrew, this is fantastic. Great work. That was really exciting stuff, and I think also it just feels like there's a lot that is practical that you can take from here into whatever software you might be writing. This is all open source. I dropped a link to your PR, Andrew. Hopefully that's the right thing to drop. But this is all part of Omicron, which is our control plane. So if you want to go explicitly check it out, definitely go for it. And look for the Andrew. I think you've even integrated the debugger now too, haven't you? I know it's it's on the way anyway.
That PR is the debugger, I think.
Nice. Yeah, there we go.
Yeah, that's what I opened up today, and it was just because I wanted to add the toggle stepping and like fast forward functionality essentially before I opened it up.
Well, a lot of great object lessons, and then there was one other question in the chat, like, what do you call this model? I mean, to me, it's kind of an actor model. I mean, I'm not sure.
I'd say like just like event-driven state machines, right? Like, yeah, right. So there's another model. I guess it was popularized, I don't know, maybe 10 years ago or something. And it's not always useful for a variety of reasons, but like you have this queue, like CQRS, right? Command Query Replay. I forget what it stands for. But essentially, you have this queue of objects, and that allows you to do the same thing, or this queue of like HTTP requests or whatever, and you can replay them through your downstream system. And so, like, people were building similar systems like this so like they could debug their business logic essentially by recording all the information that came in from the outside world through this queue. I mean, the key problem is like now you're recording an indefinite amount of information, and you can't take like a global snapshot of all your microservices like consistently. So like it doesn't really work for very large systems. You can think about modeling many systems like this. And yeah, I mean, that's one of the takeaways. Another one is just like, if you structure things correctly, like it's a few days of work to really build a debugger, especially in a language where, crates or like tools like libraries are open source that you can just build upon. Like I didn't build my own like readline library, and I didn't have to wrap anything in RL wrap. And yeah, I didn't build my own command line parser. Like those libraries exist in Rust, and it's the ecosystem as much as anything that makes stuff like this possible to do quickly.
Awesome. Well, great work. And should you have an Oxide rack, this will be the first thing you see is Andrew's software. You'll see a really amazing terminal experience. One that has had much of humanity's scarce resources poured into it because it's gorgeous. So great stuff. Andrew, thanks for joining us. I'm just going to tease next week a little bit, Adam, if you don't mind.
Do it.
So next week we are going to be talking about the cable backplane, and in particular a bit of a mishap with the cable backplane and how we debugged it. We're going to have some terrific guests. We're going to have a mechanical engineer from our manufacturing partner, and we are going to have an engineer from Samtec, which is our cabling partner. So we've got 2 terrific engineers along with Robert Keith here at Oxide. And that one is going to be a really fun discussion. So join us next week for our special guests.
And is that on Monday, Brian?
That'll be on Monday. Yep.
Great.
Excellent. All right, Andrew, thanks again.
Yeah, thank you.
Take care, everyone.